In this problem, we are asked to find the period and the location of all asymptotes and sketch two cycles of the graph of y equal to a negative 1/3 secant of 1/2 x plus pi over 4. In order to sketch this graph, we will recognize that it's going to take the graph of secant and take all those y values, multiply them by 1/3, so compress them vertically, and then finally multiply it by a negative, which is going to reflect it across the x-axis. We can take all this into consideration by looking at the graph of y equal to a negative 1/3 cosine of 1/2 x plus pi over 4. We would know that the cosine of 1/2 x plus pi over 4 would have its reciprocal of secant of 1/2 x plus pi over 4. Multiplying cosine by a negative 1/3 would compress those y values and then reflect it over the x-axis, giving us a template to sketch the secant function. If we look at this, we would recognize that our amplitude is given by the absolute value of a, which is 1/3. This means the range of our cosine function is between negative 1/3 and positive 1/3, which tells us the range of our original function is between negative infinity and negative 1/3 and 1/3 to positive infinity. We are now ready to find the period of cosine. We know that our period is given by 2 pi over b, or 2 pi divided by 1/2, which is equal to 4 pi. We also know that our phase shift is given to us by a minus c over b, or a minus pi over 4, divided by b, or 1/2. If we invert and multiply, we'd get negative 2 pi over 4, which is equal to a negative pi over 2. We could sketch our one-cycle interval for cosine as 1/2 x plus pi over 4 ranges between 0 and 2 pi. Subtracting pi over 4 and dividing by 2, we will have that range of x between, first of all, subtracting pi over 4, multiplying both sides by 2, I get a negative pi over 2 to 7 pi over 2, which is indeed 4 pi units. We will now sketch the axes and sketch our graph of the cosine function. In this function of cosine, on its interval between negative pi over 2 and 7 pi over 2, we know since a is negative 1/3 that it's going to reach its minimum value of negative 1/3 at the start and stop of its interval. Likewise, it would do the same on its next interval between negative pi over 2 and 9 pi over 2. We will also recognize that halfway between the interval of negative pi over 2 and 7 pi over 2, or at 3 pi over 2, it will take on its maximum value of 1/3. Halfway between negative pi over 2 and 3 pi over 2, it will hit an x-intercept, and halfway between 3 pi over 2 and 7 pi over 2, or 5 pi over 2, it will hit its other x-intercept, sketching one full cycle of the sine or cosine function. We can carry on in this process because we know that halfway between negative pi over 2 and 9 pi over 2, it's going to hit its maximum halfway between each of the low and high points. It will hit its x-intercept, giving us our second full cycle. We are now ready to sketch the secant function. We will know every time the cosine takes on an x-intercept, we will have a vertical asymptote. These are happening at every other odd multiple of pi over 2, and then we can use our reciprocal relationship to sketch the branches of our secant function.